Lesson 2. The standard deviation. Probably the key idea of this whole unit. And this is where we're going to start out doing these by hand. And this is where we're going to say very quickly, wow, like for 10 items, it takes me 40 calculations to do this by hand. I'm going to type the items into a list and let my calculator crunch the numbers. Prerequisites. Here's what you need to remember how to do. It says find the mean, the median, and the mode of the following data set. Let's do the first one by hand. Let's do the second one using the graphing calculator technology. So turn your calculator on. I'm going to go into menu number 1. To find the mean, what do I do? To find the mean, what do I do? Add them up, divide by how many there are. Symbol for mean, this thing, or x bar. It's going to be 5 plus 12 plus 8 plus 12 plus 16 plus 1 plus 9 divided by, how many are there, Matt? 7? Yep. Oh, but I have to remember one more thing, Boston. Please put the top in brackets because there's more than one number on the top. Calculate the mean, please. Liam, what'd you get? Yeah, so press menu. And then option 1, right? To get out of stuff, hit exit twice, hit menu twice, well actually it's hit clear twice, hit exit twice, hit menu twice. That'll bail you out of almost everything, I hope. The only other one is sometimes second function exit yellow is quit. You might be in something and it's stuck. You might have to quit. We'll play around with these. I get 5 plus 12 plus 8 plus 12 plus 16 plus 1 plus 9, close bracket, divided by 7. Do you get 9? Yes? What about the median? Now, sometimes students will say, hey, Dueck, the median is 12 because that's the 4th term. No, I have to do something first. What do I have to do first? I got to put them in order, smallest to biggest. So really quickly, I'm going to go 1, comma, 5, comma, 8, comma, 9, comma, 12, comma, 12, comma, 16. Did I miss any? 1, 2, 3, 4, 5, 6. Okay, Shay, what's the median? Also 9. What if there had been an even number of terms? What if, don't write this down, what if I'd also had a 20 right there? I would take the 4th and 5th, because there's 8 terms, I would add those two together and divide by 2. I would go 21 divided by 2. I would say the median is 10.5. However, we had an odd number of terms, which made it easier. The last thing, the mode. What's the mode? 12, the most common one. Okay. So let's do it by hand. Number 2 says find the mean, the median, the mode of the lengths in the table, and it gave us the frequency chart. You know what? Let's use the frequency chart. So now, Joe, I'm going to go menu and option number 2, which is stat. Now, you might have a list in list 1 and or list 2. Remember to delete a list. If you go F6, which is arrow sideways, that brings up delete all, which is F4. So clear your lists. And if you can't get that, now is a chance. Now is your time to ask me. Clear your lists out. Mine will almost always, because mine doesn't save it when I close the program down, Liam, I'll always be starting out with blank lists. So you'll have to remember, clear your lists from whoever was using your calculator last. Everybody got it cleared? Oh, and then Shay, hit F6 until you're back to the graph, calc, test, intra dist menu. Okay. You okay there, Devin? Move your cursor keys until you're list 1, row 1, and let's type in the lengths 5, 6, 7, 8, 9. And then arrow sideways so you're in list 2. Let's do the frequencies. 6, 5, 6, 3, 4. Who remembers what we hit now? Okay, calc. You have to set everything up, and that's a good habit to always get into. Double check, set. Mine says the list is in list 1, which it is. But under frequency, mine says there's one of each. No, I have a frequency list. What list did we type the frequency list in? So I'm going to go F2 list, select list number 2, enter. You might still have list 1 and list 2 depending on who used your calculator last. I don't know. How do I get back to the previous menu, Joe? Look up. Okay. Menu would take us back to the main menu. I don't want to go back to the main menu. I just want to back up 1. So right now you should have this screen. Anybody not have this screen? Okay, how do I find the information? How do I do the calculations? We're doing 1 variable stats this year, not 2 variable stats. So 1 var. Okay. Which of these was the mean? Okay. X bar, 6.75. Which of these was the median? Median, 7. Which of these is the mode? It's bimodal. What are the 2 modes? And you'll notice it does actually have them both, doesn't it? Oh, and then it says the number of modes. There's 2 of them. That's what that n equals 2 means. It's saying, hey, there's 2. What are the 2 modes? 5 and 7. Mode is easy to find from a frequency chart. You just find the 2 biggest frequencies. The other ones are a bit trickier, but doable. So you can do these by hand. But I think today is the day I'll make you all converts to saying, I'd like to use the technology. Number 3 says this. What information does the mean give you about a data set? The average. So example 4. 2 different groups of 10 students are given the same test. And these are the results. A says, determine the mean score for each group. Do you want to do this by hand or do you want to use the technology? Technology? So, clear your lists. Oh, how do I get out of this, Joe? See? How do I get out of this menu? Well, I haven't got there yet. Exit 1 more time. Now I'm back to that F6, delete all, yes, delete all, yes. And just to be different, let's type group A in list 1, let's type group B in list 3, so there's a space between them so I can see it easier. So, you there? Following along? By the way, do not suddenly just say, oh, I'm going to do this all by hand. Yeah, right? So you get this screen, you clear the list? Okay. So group A, 6. So I type the first list into list 1, and I'm going to go arrow sideways twice, and I'm going to type the second list into list 2. 3, that's what I said. Listen closely. List 3. When you've got both lists typed in, just look up so I know that you're done. Aaron done? Almost? Good? Yeah? Johnson done? Yeah? Anybody not done? Okay. Oh, and I'm going to go back to this menu. I want to do, oh, what do I want to hit now? Okay, I'm going to go calculate. Now we're going to do list 1 first. So let's go set. List 1. For the frequencies for list 1, what do I want the frequencies? Shay, question? Marcus, question? We're okay? So we're in this menu now. What do I want for the frequencies? Is this an actual frequency table? Oh, what do I want for the frequencies then? 1. Oh! F1. Okay. Exit. 1 var. What's the mean of group A? 72. I'm going to go like this. X bar of A is 72. How do I go back, Liam? Oh, exit. Set again. This time I don't want to do list 1. I want to do list, where did I type it? 3, yes? So F1, list number 3, enter. Is the frequency okay though? I want one of each. Liam, we're good with that? Yeah? Okay. How do I get back one menu, Liam? Exit. 1 var. What's the mean of group B? Sierra. Also, oh, I guess these classes are identical. Or are they? Look at the data. Do you notice any differences between group A and group B? Looking at the actual numbers that are there. Boston. Oh, using math words, Boston. What? Outlier? Group B has a way bigger spread. And that, Jordan, is what we're interested in. What we want to do today is try and come up with a mathematical way so that I can assign a number that talks about how spread out something is. If the number is 0, everyone's identical. Otherwise, the bigger the number, the more spread out your data is. Group B has a bigger spread. So question C says, how are the scores spread around the mean? You can see these are clumped really close to the mean. Here the mean is 72. There's a 100, there's a 40, there's outlier. This is way more spread out. And again, let me repeat, our goal today is, can I come up with a mathematical way? And there is one, and Binder, it's lengthy, not tough, it's lengthy. We're going to do it by hand, and I'm going to say, oh, for Pete's sakes, this will do it for us. I want to come up with a number that describes how spread out data is. If you're a medical researcher, you want this number to be as close to 0 as possible, because that means your medical data is good. If you get a high spread, there's some other factor that you haven't factored in. We use this all over the place. Turn the page. We're going to give this number a name. We're going to call it the standard deviation. So the standard deviation, how spread out the data is. A larger standard deviation means you've really got a big spread in your data. Smaller standard deviation, everything's pretty close to center. Okay? And here is the process that they went through. They said, well, I want to figure out how far away the data is from the mean, from the average. And so the first thing that they thought that they would do is they would try going the mean minus the data. 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 Oops, I'm going data minus mean. The mean minus the data. The mean minus the data. And the mean minus the data. And why I slanted like that, I don't know. It's because I'm a lefty. I put 70, oh, right there. I think we can do this in our head. 72 take away 66 is 6, yes? 5, 4, 3, 2, 0, negative 2, negative 6, negative 6, negative 6. And I guess the negative means you were above or below the mean or whatever. This is what they tried first, and then they thought, maybe I'll add all these up. So can you on your calculator, so now go menu, option 1, can you add 6 plus 5 plus 4 plus 3 plus 2 plus 0 plus negative 2 plus negative 6 plus negative 6 plus negative 6? Maybe this will give us a number that describes how spread out the data is. What do you get? Strangely. 0. Dope! Why? Because these positives get canceled out by these. But this is what the first person thought of it. I get 0 every time because my minuses are canceling out my pluses. Then they said, wait a minute. I do know a mathematical operation that always gives me a positive answer, that will always turn a negative into a positive. Why don't I try squaring all these numbers? Won't that give me all positives? So they started out deviations from the mean, and then they said, hey, maybe deviations from the mean squared. 6 squared, 36. 5 squared, 25. 4 squared, 16. 3 squared, 9. 2 squared, 4. 0 squared, 0. 2 squared, 4. Negative 2 squared, positive 4. Negative 6 squared, 36. Negative 6 squared, 36. Negative 6 squared, 36. Let's add those up. Those won't give us a 0. So can you go 36 plus 25 plus 16 plus 9 plus 4 plus 0? By the way, Boston, this is what you have to do every single time to calculate the standard deviation. Or you can get the calculator to this one. And we're near done there. What is 36 plus 25 plus 16 plus 9 plus 4 plus 0 plus 4 plus 36 plus 36 plus 36? 200 and what? 202? Anybody else? So the sum of the squares is 202. Then they said, what I'd like to do is I'd like to take the average of this 202. How many pieces of data were there grand total? 10. I'm going to go 202 divided by 10. I can do that in my head. 20.2. However, this is still too big because how did we make all of the answers positive? You know what now? I need to go backwards. What's the opposite of squaring? Square root. The standard deviation is going to be the square root of 20.2, which is what? It's going to be 4 point something, I know that. 4.49. This data has a standard deviation, a spread of 4.49. Now, I'll show you the math way that we write these instructions in just a second, but let's find the standard deviation for group B. So the first thing that we would do is we would go the mean minus the data, the mean minus the data, the mean minus the data, $72 take away 40, that's 28. 72 take away, no, that's not 28, Mr. Dueck. That's 32. Good gosh. Nope, wrong calculator button. $72 take away 51. 21. $72 take away 59. 13. 72 take away 63 is 9. 0, negative 6, negative 6. 72 take away 85. Negative 13. 72 take away 94. Negative 22. 72 take away 100. There's my negative 28. I have it in here somewhere. Square all these. Sadly, these ones I can't do in my head. 1024. 441. 13 squared I know is 169. 9 squared is 81. 0 squared is 0. Negative 6 squared is 36. Negative 6 squared is 36. 13 squared is 169. 22 squared, I have no idea. 484. 28. By the way, you'll notice I'm just ignoring the negative because when I square the negative, it's going to vanish anyway, so I didn't type in negative 28 squared, I just typed in 28 squared. 784. Add all these together. You get 3,224? I'd like a confirmation because I did a lot of calculating there. Simon, you get the same thing as me? Anyone else? I want at least 2 or 3 confirming mine. Yes? 3,224? Now, 3,224, take the average and square root that answer. Square root, second function x squared, shift x squared, if you haven't found the square root button yet. And answer button is second function negative sign. You get 17.96? No? Yes? No? Yes? Yep. Okay. The symbol for standard deviation is this. It's this. It's a lowercase sigma for those of you who are scorekeeping at home. You can write standard deviation, but it's way easier to do that. Oh, and that's what your calculator will show you. Did you get 17.96? Okay. Hey, let's go back to our menu. Dope. Dope. Let's go back to stat. Let's go back to calc. Let's all set so that we are list 3. Frequency of 1, so make sure we're all at the same place. You there okay, Joe? Let's exit back to here. Hit one variable. Is there a 17.95555 that appears anywhere here? Oh! There's the symbol for standard deviation on my calculator. X stands for the data. There's its attempt to do this little Greek letter. N is the number of data. The standard deviation of all the data is 17.955. Now there's a bit of a problem because there's this and then right below it there's one with an N minus 1. Don't do that. Problem, Adam, or not? Oh, you gotta go, okay. Yours doesn't have the X in front of it? Oh, even better. Good. Yours just has this, just the symbol. Well, it's a sigma, not an L. Show me your screen. It's 20. The standard deviation of the data. Okay. So let's make a little note here on calculator. Is that what yours says? Sorry, mine says a little bit different. Hey, let's double check really quickly. Let's go exit, set. Let's put list 1 and see if that gives us the standard deviation of that we got at the top of the page. So list 1, enter, exit, 1 var. Do I get the 4.49? I'm going to argue that's a little quicker. But think about what we did. We said, you know what? First of all, find how far you are from the mean. But because you're going to get some negative answers, square everything to get it all positive. Add those up. Divide by how many there are. Oh, but then square root because you squared everything. That's the standard deviation. That's the number that describes how spread out data is. Can you open your workbooks, please, to page 209, page 209. Page 209. Under the B2, under the O, under the N9. Anybody not have their workbook here? I'll loan you one. You can be bringing it from now on. We're going to be using it from now on. Don't write in this one, you can follow along. Okay. So last day we talked about measures of central tendency, the fancy word for average. Today we're looking at measures of dispersion, the fancy word for spread. So consider the assignment question from the previous lesson comparing the average daily temperatures in Nanaimo and Toronto. If you were to carefully type these in, you would find a mean of Nanaimo of 9.5 degrees, and Toronto also has a mean of 9.5 degrees. You would also find that they have the same median. Does that mean that Nanaimo and Toronto have exactly the same climate? No. Toronto has a way bigger spread. Toronto gets way colder in the winter and way hotter in the summer, even though, as it turns out, their average temperature and their median temperature are the same. So the temperatures in Toronto are more spread out. In fact, if you look at the graphs, the hollow circles are Toronto. You can see you go higher and you go lower. The shaded in circles are Nanaimo. The fancy word for spread is dispersed. It says using only a measure of central tendency to describe the data does not accurately tell you everything about the cities. You might assume that they were the same. If we include a measure of dispersion together with a measure of central tendency, we can get a clearer understanding of the similarities and the differences. We've already met one measure of dispersion last day, the range, the difference between the highest and lowest temperatures. What's the range of temperatures for Nanaimo? Look at the chart. What's the biggest temperature here in Nanaimo? 18. What's the lowest? 3. The range of temperatures is 15 degrees. What's the range of temperatures for Toronto? What's the highest that appears in the chart? 23. What's the lowest? -4. So what's the range? 23 minus 4. 27 degrees, yes? But one disadvantage of using the range as a measure of dispersion about the mean is that it only uses 2 data points and it could be skewed by outliers. So a better measure is the standard deviation. Turn the page. The standard deviation is the measure that describes the variation or spread between data values and the mean. A low standard deviation means most of the data values are close to the mean. It means you have consistent data. High standard deviation means that most of the values are scattered further. It means you got inconsistent data. If you're doing research, something's wrong. Standard deviation is also often used to compare 2 sets of data. The symbol for standard deviation of a population is given by that. The standard deviation of a sample is given by a lowercase s. We're not going to be that fussy, Joe. We're always going to assume that we're finding the standard deviation of a population, and so we're just going to use that symbol there. But if you go onto an advanced stats course, you'll find that they're going to distinguish between the overall population and the sample. You guys would be a sample. The school would be the overall population, if we were looking at Pitt Meadow Secondary. Here's the equation. So what? First of all, this means the sum of. So here's what this means. Devin, this says find the difference between your data and the mean. X is your data, mu is the mean. Square the answers to get rid of negatives. Add them up, the sum of. Divide by how many there are. Square root your final answer. That's how I write that 1 page of instructions in one equation. Here's the procedure. Now, they're actually going, I went mean minus data. It doesn't matter the order, but since they're going data minus mean, let's go data minus mean. So instead of going 72 minus everything, we should have gone everything minus 72. Fair enough. Square the answers. Add them up. Divide by how many there are. Square root. We're going to do one more by hand, and then we're going to use the technology. Next page. So here's the heights of the Cobras basketball team. First of all, it says calculate the mean height. Okay. Menu, run. The mean height is going to be bracket 170 plus 182 plus 193 plus 193 plus 212, close bracket, divided by, how many are there? 1, 2, 3, 4, 5. Yes? B says, calculate the standard deviation, that's the symbol, using this equation. So here's the procedure. First, we're going to go 170 minus the mean. What's 170 minus 190? Negative 20. (182) minus 190. Negative 8. 193 minus 190. Positive 3. 193 minus 190. Positive 3. 212 minus 190. 22. If you add these up, you'll get 0. That's why we don't use those. Instead, we square all these to get rid of the negatives. Negative 20 squared, 400. Negative 8 squared, 64. 3 squared, 9. 3 squared, 9. 22 squared, I have no idea. What's 22 squared? 484. Let's add these guys up. $966. Now we go 966 divided by how many there are? And then take the square root of that answer. Divided by 5. Square root of that answer. 13.9. This tells you something hugely important. You don't know it yet, but it tells you something hugely important. So Bender, we've done it by hand, yes? Ugh. Let's do some of this using the technology. So it says using a graphing calculator to determine standard deviation. They're giving the instructions for a TI-83, which is not what I've given you, but I taught you in the last lesson how to type everything in by graphing calculator hand. So use the notes from the last lesson, and let's jump straight to finding the mean and the data from a frequency table, example 3. Okay. It says the frequency table shows the number of hits per game by a baseball player during the course of 1 month. Let's enter this into our graphing calculators. How? You know what? Figure it out. I'm going to freeze the screen. See if you can clear your lists and then enter that in, and then go calc set and make sure you set the tables correctly. Am I converting you? Am I converting you to the technology? It is easier. Oh, I did these by hand in high school, and even then, the standard deviation was so useful you didn't mind doing it because I haven't even showed you where you can use it. It is nerdily cool where you can use this, but the calculations, which Try finding the mean and the standard deviation. I think you should get this. I hope. 1.3. Let's see. The mean 1.348, let's say. I don't know how many decimals did it say? Oh, to the nearest tenth. 1.3. Standard deviation is what? Sorry? Oh, 1.087, this one, right? 1.1. You can also, turn the page, you can also do it, or next page over. You can also do it visually. Sam, stay with me. A little fidgety, I know. It says, consider the histograms representing the class results of 2 math quizzes. Johnson, you alive? Sure? Take a look here. So here's the marks. Which of these looks more clumped together and which of these looks more spread out? And convince me. First graph or second graph is what? More spread out or more clumped together? More clumped together? Well, let's see. What score showed up the most here? That's the frequency. What score showed up the most here? 3. And then, looks like almost everyone else got either a 2 or a 4. I would argue this is clumped together because you have a huge peak here with a lot of the data and still a fair amount of the data there and there. Barely any data on the outliers. I would say that this here is less spread out. Here, is there any peak anywhere? In fact, this is way spread out. Everything's even. There are no outliers, but there's no. The mean is everyone. There's no mode. You see it? In fact, there's 5 modes. This would be quint modal. So, without doing any statistical calculations, which quiz has the bigger mean? I think your average here is about there, probably the biggest one. I think the average here would be right about here, dead center of this graph. What's the value for dead center of this graph? 5. What's the mean here? Okay, you know what? The stats quiz has a bigger mean. But which one is more spread out? Which one has a bigger standard deviation? Also, the stats quiz. Let's see if we can use our graphing calculators to confirm this. Let's type this into list 1. So exit, delete all, yes, delete all, yes. How will I type this? How will I translate this into a frequency table? Well, Danielle, here are the marks that appeared. I guess you can get a 1, a 2, a 3, a 4, or a 5. That's going to be my first column. 1, 2, 3, 4, 5. How many kids got a 1? 2 would be this high. How many kids got a 1? 1. How many kids scored a 2? 3. How many kids scored a 6? Sorry, how many kids scored a 3? Whoops, 6. How many kids scored a 4? 4. Right, Boston? How many kids scored a 5? See how we're reading this? You see how we're reading this okay? Yeah. Yes? Let's type the second graph into lists 3 and 4, because I don't want to delete this. So I'm going to go like that. What are the possible scores, Sierra, for the quizzes that they got on this quiz? So I'm going to go list 3, 3, 4, 5, 6, 7. How many kids scored a 3, Sierra? How many kids scored a 4? Okay. 3, 3, 3, 3, 3. Is that okay, Jordan? Okay, let's crunch the first set of data, which is in which two lists? Okay, so let's go calc, set, list 1, list, oh, I'm already list 1 and list 2. I don't know if you guys are, but I already am. Yeah? Exit, 1 var. The mean, I said it was right around 3. Looks like it's a tiny bit above 3. Standard deviation, 0.99. So, on the quadratics quiz, mean 3 point, what was it? 0.1. Sorry, 0.7. And the standard deviation was 0.99. Oh, actually, standard deviation isn't 0.99. If I round off properly, it's actually 1.0, isn't it? Let's do that properly, Mr. Dueck. Now let's find the second data. Exit. Set. What list did I type the data in for this second graph? List number what? So list button 3. And what list did I type the frequency in for the second graph? Right? You with me? Yeah. Yeah? Okay. Exit 1 var. So this has a mean of 5 even, and a standard deviation should be way bigger. Let's see. Oh yeah, 1.4142, 1.41. So numerically, this one is spread out further, and I can see it from the graph. Here, stuff is clumped towards the middle. Is that okay? So what's your homework? I'll get you started, and then those of you that want to work on your test, you can spread out either to an empty desk or on the edge of your desk, and you can work on the test too. Homework. Number 2. Number 4. Five. 6. I'm going to put a star next to this. I haven't talked about this. I'm curious if you can figure it out. Otherwise, I'll talk about this next class, if you ask me. 7. 8 is good. 9 is good. 10, 11, 12, 13, 14. Okay. You can do these by hand, but it's not a course requirement. It says you're allowed to use technology. Boston, I will strongly encourage you. Use the technology. You saw how much for even 10 pieces of data, which is not a lot. That was a lot of writing on those first 2 examples. Have I converted you?